Yeah, so I'm Noah Krause. I'm a support engineer over here at DataWire, and we build the Ambassador API gateway and with Ambassador Edge Stack. And I'm here to talk about scaling microservices on Kubernetes with the Ambassador Edge Stack and the Consul service mesh. So usually I like to start off these kind of things with a little TLDR. I just kind of preview what I'm going to be talking about during this presentation. So the first thing we would talk about is treating your infrastructure as cattle, not pets. I'm sure a lot of us have heard that analogy before. Application modernization leads to heterogeneous infrastructure networks, meaning that when you start to modernize your apps and deploy them in Kubernetes and containers, you oftentimes will have a bunch of different kinds of applications running in different data centers, whether they're in Kubernetes or in hosted in virtual machines. Networking is a real challenge when you have this on, because you got to try to fight with how to get connections between your microservices that are running in Kubernetes, between those and the ones that are actually running in your virtual machines. And then the use case, the edge, or the networking complexities at the edge and at the service level have different requirements and different use cases. Great. Yes. So the great. So the traditional approach to data center management is, sorry. Can you guys see my notes? Sorry.
No problem. At the moment, we can't see the notes. We can just see your slide.
Perfect. Okay. So now I'm sure by now we've all heard the pets versus cattle analogy. Traditionally, we built data centers to be like a loving home for our applications. We had applications, databases, load balancers, et cetera, all hosted on a dedicated server. And these specific machines were all vital to the ongoing operations of our organization. And as such, we gave them to people to not just own, but to love and to care for them. IT departments gave them names, kept them happy, and nursed them back to health whenever they got sick. We designed our data centers so that these machines knew who they were, what they were supposed to do, and who they were supposed to talk to. And we set up processes to keep them safe from harm, make sure that if they got hurt, we knew what caused it and how to fix it. And in this way, we kind of treated these machines like pets. Each of them meant something special to us and were very important, and we really wanted to keep them happy individually. While the nice thing about this method of organizing a data center was that it was really clear how to manage it. You could set up processes like change management that would keep your firewalls secure. Your applications lived almost entirely on dedicated machines, and so that networking is comparably simple. Firewalls were used to deny most traffic, and processes like change management were put in place to make sure that we knew how each server was talking to another. This also simplified authentication and encryption. Requests from clients really had only one destination to go to, so we could mostly be confident in the security of the system, even if the security was only handled at one source. TLS could be terminated at a load balancer, and the application that the traffic was being directed to could generally trust that the request was secured at the load balancer layer. And the same thing with, and then thus the application could directly also handle authentication, since there was really only one endpoint that clients were hitting. So while this networking and management simplicity was nice, there were some serious drawbacks from an operations perspective. Since individual machines were so important, if one went down, it could really be an emergency. We could be constantly paged about production outages that required an intimate knowledge of how to nurse a server back to health. And this kind of dedication to individual machines is what led us to need to create the change management processes that we liked in the first place. Since each one was different, we really needed to know exactly what happened to it and how exactly that special machine needed to be fixed. Dedicated hardware also made scaling up more complicated. So because you had to dedicate a single virtual machine or a single server to an application, you ended up having to spin up a bunch of different things. Virtualization made this easier where you didn't have to buy hardware for it, but we really ended up treating these VMs as a group of special pets. And the problems only grew more severe as we scaled. And so as our collective technology footprint grew, fears about being able to keep up with demand were pretty real. And then we decided, or eventually with DevOps practices, a better way started to come around. We decided that what if instead of treating these servers as special individuals and pets, we took advantage of new technologies like virtualization, containerization, and Kubernetes to decouple applications from servers and instead treat them like a fleet of similar entities that served a similar purpose and did a similar thing. That way, if one got sick, we could just swap it out for a new one without much pain. And this way, we really didn't care who an individual machine was, what it was supposed to do, or who it was supposed to talk to. We just cared about the purpose that it served as part of the collective. So now we're treating machines as cattle. We no longer give any machine a special name or any special treatment. A single machine is part of a collective and can easily be replaced. And this really helps us solve some of the problems that we saw with our dedicated server setup. We now do not really need to have an intimate knowledge of a single machine in order to solve a problem. If something went wrong with a server, it's pretty trivial to just spin up a new one and redeploy our application instead of needing to nurse a server back to health. So we can now deploy applications on any machines and thus scale easily without needing to devote as much time to provision and network the machine into the right place in our data center. Because a lot of this can just happen with DevOps tools and CI. So this has led us to developing new workflows for building software. Since we're able to package applications into containers that can run at almost anywhere and scale easily, we're able to break apart a monolith into microservices that we can optimize and scale the parts of the application that we need to, individual from the parts from the rest of it that's actually handling load fine or not being overloaded. And this microservice approach has also allowed us to have smaller, more focused developer teams that are able to iterate and build software more quickly and deploy it without impacting the rest of the organization. While this brave new world of containerization, microservices, and Kubernetes has brought a ton of advantages in terms of agility, scalability, and all those other abilities, there are some big pain points that have really been introduced as a consequence. The biggest and most obvious is the networking. Networking complexity has scaled dramatically. One of the first things that you'll notice, or one of the first questions that you'll run into when you're trying to implement a microservice or a Kubernetes or container-based architecture is how do we even start implementing it? The networking complexity of your data center grows dramatically when you start moving to microservices. HTTP calls are now taking the place of function calls. And on top of that, we have taken our single entry point of our monolith and turned that into multiple services that are now directly interfacing with clients. Kubernetes simplifies a lot of this networking for services that are already deployed in it. But what about the ones that we are still running outside of it? What about the ones that we are still running outside of it? How do we handle requests between services that are running inside of our Kubernetes cluster to the ones that are still running outside? And what about security with all of those new network interfaces? Will each service on the edge now be in charge of handling TLS termination and authentication? And how will we be able to know that, how will we be able to know that how will we make sure that we don't have vulnerabilities and secure the traffic between services within our cluster and data center? So the solution to this problem is really twofold. The first thing that you need is an API gateway or edge management layer or edge management software that will handle your layer 7 ingress routing to all of your different types of applications that you now have running directly at the edge. We'll handle load balancing between replicas of these applications, and security and reliability and authentication as a single entry point for your entire data center. The second is a service mesh that you connect all of the services in your data center together so you can enforce encryption and other security policies on service-to-service calls. The purpose of the API gateway is to be a centralized entry point for all of your microservices connected to the edge. Like the monolith load balancer, it will be in charge of terminating TLS on connections from the client. Unlike the load balancer, however, it's operating at layer 7, which allows you to route a variety of different services that are all being requested from different clients, all behind the same entry point, as opposed to needing a bunch of different IP addresses that your clients are talking to or having to manage that. Also, unlike the load balancer, it is running within your Kubernetes cluster, which allows it to directly expose your services, take your services that are in Kubernetes, taking advantage of the service discovery and networking configurations already implemented by Kubernetes. And because it's operating at layer 7, this single entry point will also be able to handle more complex request-based actions like authentication and rate limiting. This means that you can skip having to handle authentication in each and every individual service at the edge and simply let the gateway take care of it, which frees up your developers from needing to implement and maintain authentication code that can span multiple services. The service mesh is the controller for all of the networking that is happening within your data center. So whether your services are running in Kubernetes or outside of Kubernetes and VMs, the service mesh can connect all of these together. While Consul is unique in that it allows you to connect all of your services, where traditional or other service meshes are really only able to run in Kubernetes. Consul can connect services that are inside and outside of your cluster together into the same network, so you can take advantage of network management and service discovery all within the same management interface in your throughout your entire data center. And once all of your services are connected and managed under the same control plane, we can now easily route to them and enforce network security policies like MTLS for all of our services, whether they're microservices or monolithic. The Ambassador Edge Stack is capable of integrating directly with Consul for service discovery and routing and security to all of the services within your data center. Together with Consul and the Ambassador Edge Stack, we're able to mitigate many of the networking pain points that come with moving to decoupling applications from machines and treating machines like cattle instead of pets. So in summary of these slides, it's really important to treat things like cattle, not pets, because it allows you to scale better. It keeps you from having to focus on maintaining single machines and instead focus on building good applications. Application modernization leads to heterogeneous infrastructure networks, which can really add to the complexity of your data center. This networking is a real challenge with microservices, especially when you still have VMs that are running outside of Kubernetes that you need to interface with. And the networking challenges at the edge and between service to service calls have different use cases and have different requirements. And then I now also have a quick demo to show you about how Ambassador and Consul can integrate together so that you can use Ambassador to route to services that are running outside of your Kubernetes cluster, in VMs outside of your Kubernetes cluster. So let me just pull up my. Great. Can you guys, yeah. So here I have, I provisioned a virtual machine, that's an application that's running in a virtual machine that is called our Shopfront application. And I need a web browser too. Sorry, can you guys see my terminal or is it not sharing?
It was sharing your browser, but now it's not sharing.
Yes, great. Can we see everything now? Great.
Currently seeing slides.
Awesome. Yeah, so currently I have a virtual machine provisioned. I provisioned it with Terraform because it makes it really easy to provision cloud software. virtual machines and Kubernetes clusters all kind of within the same network. Being able to interface these networks together is really an important part of this, so that the virtual machine can talk to a console that's running in a different network environment. So if I go to this IP address that was provisioned, we will see that I have this is a Spring Boot application that's being hosted on a virtual machine right now. Now inside of this virtual machine, and apart from that, I also have a Kubernetes cluster running that has Ambassador. It has Ambassador, Consul, and a example, just very basic HTTP endpoint that gives us a random quote back to it. So if I just to show how things are working with Ambassador, if I grab the IP address of Ambassador, which is acting as our API gateway in this circumstance, and I send a curl to it, to the HTTP endpoint that I have provisioned to get a quote, you'll see that I'm getting a response from that GET request to the HTTP endpoint. So now I also have Consul provisioned, which is allowing me to connect my HTTP microservices running in Kubernetes to the shopfront application that's running in that VM. At least it should be. Oh no. So inside the VM, in order to get it to so I'm SSHing into the VM in order to connect it to the Consul agent. Inside the VM, I have a JSON endpoint that's registering it with the Consul agent, and restarting the Consul service should register this new endpoint with Consul, so I've been able to route to it from within Ambassador. Although there appears to be something misconfigured where I'm not able to actually talk to the Consul service right now. But so I can explain how that would happen. So what's supposed to happen is I'm spinning up the Consul agent on this virtual machine, and it's supposed to be connecting to the server that's running in the cluster. And then from there, I'm registering a new service with Consul in the cluster. And then with that, I'm able to have services that are in Kubernetes and services that are in Consul, all running together under one single management control plane. Then with Ambassador, the configuration to expose these services is fairly simple. It's a CRD based. It's a CRD definition that it takes you configure Ambassador to talk to the Consul server that's running on the cluster, and then you tell it to use that Consul server in order to do service discovery. So then what would happen is the Consul server would then look up the service that is shopfront from, or Ambassador would look up the service that is named shopfront in Consul and know that it's supposed to route to a VM with the IP address that was registered in this definition. So what this would then allow us to do is to be able to use Ambassador's ability to terminate TLS, and then also use Ambassador's ability to terminate TLS, and then also be able to use the MTLS secrets or the Consul connects TLS or MTLS capabilities to route to services that quote services in the cluster and that VM that's running outside of it. I'm sorry the demo seems to have not gone as well as I had hoped. But yeah, I think at this point, I would like to open up the floor for any questions that are out there.